Hey, welcome to Number Club. This is Year 1 Pure, Chapter 3, Lesson 5, and this is Quadratic Inequalities. So let's get cracking. So your first question says, find the set of values for which this quadratic is less than 0. The thing you'll need to do is find your critical values for your quadratic. They are your roots or your solutions. You'll need to solve this quadratic. Now, most of the time with this type of question, you'll have something that can solve by factorizing, but every so often you might have something that needs to complete the square or use quadratic formula. It's up to you. Some people hate factorizing so much that they just use the quadratic formula, although I'd be worried about that. So we're going to factorize this. We'll get x plus 5 lots of x minus 2. It's got to be less than 0. Ignore the less than 0 for now. X is going to equal negative 5. X is going to equal 2. Sketch the quadratic. We get 2. We get negative 5. It's a U-shaped quadratic. Always make sure you pay really close attention to whether it's U-shaped or N-shaped. It's a big deal in this topic. We want the section where this is less than 0. And this is a really similar skill to what was going on when we were talking about the discriminant. We want the region where this is less than 0. The region where that is less than 0 is in here. Okay? The output is less than 0 when I put in any of these values. So if I put in negative 4, I get out something that's less than 0. Put in negative 2, I get out something that's less than 0. And so we want this single region here, just this one little region here. So we want the section where x is less than 2, but also greater than negative 5. That would be fine most of the time. If you're asked to give set notation, you might say give in set notation. You would get one region, so one set. You get something that looks like that. Okay, nice and easy. Next, find the set of values for which this is greater than 0. Now I'm going to pause for a second and see if you can predict why this is going to be more difficult. Okay, we've got x plus 3 lots of x plus 5. We've got greater than 0. And so our solution is going to be x equals negative 3, x equals negative 5, negative 3, negative 5, U-shape. And we want the section that is greater than 0. So we were looking for the section where this is greater than 0. So we had greater than 0 equals 0 and less than 0. And that's going to be these two sections. Now, two sections means that you've got two inequalities that you need to do, potentially two set notations that you need to do. You cannot give this as one inequality. There is no number that is greater than negative 3 and less than negative 5. So it has to be two separate things. So you have x is greater than negative 3 or x is less than negative 5. Okay. In set notation, this will be fine from 90% of the questions. In set notation, you've got there are a set of values labelled x such that x is greater than negative 3, or there are a set of values labelled x such that x is less than negative 5. Okay, there are ways to make it so that you can write those as one kind of major set with or included, but I tend to just write two set notations. All right, we've got this thing. This is a little bit different because it's got a greater than or equal to. Okay, now this here, I just recognise it being perfect square. Okay, you might well need to fully factorize it, but I'm not going to go through that in full. And what we find out is that there are a set of values. There's a value, just one critical value, which is where x equals negative a half. 2x plus 1 equals 0 happens twice. So 2x equals negative 1, x equals negative 1/2. Negative a half. Okay, we note that we've got a U shape. It goes like that. When is that going to be greater than or equal to 0? Well, it will be for absolutely every single value of x that you could come up with. So x just exists within the real numbers, or x can be any value. Just be careful with the greater than or equal to's and the less than or equal to's, because they'll match in your final answers with your inequalities. All right, moving on. This question here, it's got a quadratic, but it's also got this negative. You need to be so cautious with these. So we're going to multiply through by negative 1. And when you do that, you're going to flip the inequality. Okay, flip the inequality. We'll get two solutions out of this. Don't be tempted to expand this. You can just get the solutions. X equals negative 2, x equals 3. So we get, when is this greater than 0? Strictly this is what we're solving at the moment. When is this greater than 0? So we've got -2, 3. That is a U shape. Okay, when is it that that's greater than 0? Well, it's greater than 0 if x is greater than 3 and x is less than -2. Again, try it out if you want to. Try something out that works for this, like 4. Plug it into here. So you'd get negative of 6. Lots of 4 take away 3, which is 1, is less than 0. Yeah, -6 is less than 0, so that works. Okay, and try out, say, -3. So you get negative lots of -1, lots of -6, which will come out as -6. Okay, again, that works. All right. Moving on. Find the set of values for which this thing is less than 0. Now, this question, I've only made this one just to show you something, which is that you don't have to worry about doing this halving trick to make things easier to factorize. It's fine. Don't worry. Okay. You can try to factorize this thing. You'll get two numbers that multiply to make 6 and add to make 5. They are 2 and 3. So we get 2x squared plus 2x plus 3x plus 3 is less than 0. So we get 2x lots of x plus 1 plus 3 lots of x plus 1 is less than 0. So we get 2x plus 3 lots of x plus 1 got to be less than 0. So your critical values are x is going to equal -3/2 and x is going to equal -1. Those are the critical values. So we get -1, -3/2. Note that these aren't proportionally accurate. It's not really important. Just make sure that they're in the correct order. And this was U-shaped, so we can U-shape it just like that. Okay. That will be the same answer as what you would have got from this stuff up here. Okay. We want the bits where that is less than 0, and so that will be when x is between those two values. Okay, and you can try something out if you want to. You can try out, say, -1.25, substitute that into there and check whether it's correct, and if it is, then this is correct as well. All right, next. Multiply through by -1. X squared has got to be greater than 9. Moving 9 over. Oops. X squared minus 9 has got to be greater than 0. And so this is the difference of two squares, x plus 3, x minus 3. You can see why it's so beneficial to be so quick with your factorizing. -3 comes from this bracket, 3 comes from this bracket. Okay, and we want the sections where that is greater than 0, which is going to be up here, which is x has got to be greater than 3 and x has got to be less than -3. All right. So moving on. This question has a quadratic inequality with an and versus a linear. So this is much more difficult. It's quite advanced, this. Now, the first thing to do is to look at this. We've got 3x minus 10 is greater than -x squared. Now, I'm going to add on -x squared onto each, add on x squared onto each side. So we'll get x squared plus 3x minus 10 has got to be greater than 0. That is not the same as multiplying through by -1. Okay, if we were to multiply through by -1, we'd have ended up with -3x plus 10 has got to be less than x squared, and then we'd move these things over. Okay, and we'd end up with 0 has got to be less than x squared plus 3x minus 10, which is what we've got anyway. Okay. The little bit's pointing at 0, the little bit's pointing at 0. Okay, so you could do it in a much longer fashion if you wanted to, but if you're just adding on or you're just taking away, you don't need to worry about flipping that inequality. It's only going to happen if you're multiplying through by a negative. Okay, so we have x plus 5, x minus 2, got to be greater than 0. So we're going to get -5 and 2 are our two solutions. We want the section where that's going to be greater than 0, so the bits from up here. That is x is greater than 2, or x has got to be less than -5. 2, -5. So we're going to get that, or we're going to get, -5, sorry, and 2, wrong order, -5 and 2. We're going to get that, or we're going to get that. Okay. With the 2x plus 1 is less than 0, it's not overly complicated, really, pretty simple. So let's crack on with it. We've got 2x plus 1 is less than 0, so we've got 2x is less than or equal to negative 1, x has got to be less than or equal to negative 1/2. Okay, now negative 1/2 will be between these two, negative 1/2, and x has got to be less than or equal to that. So it's that direction. Now, the AND question means that we're looking for where both things are true at the exact same time. Now, both things are true at the exact same time. It's not working here. It's not working exactly at negative 5. It works when x is less than negative 5. That's for AND. That's for this question. That's what's being asked. If it was an OR question, if you were being asked OR, okay, if you're wondering, the OR version would be if x is less than or equal to negative 1/2 or x is greater than 2. Okay, but it just has to work once. With OR, you don't want the blank sections. With AND, you only want the bits where both are working. Okay, moving on. Here's an exam question. So this exam question, there's a few exam questions coming up, by the way. This exam question, you might want to pause right out. I'll pause now. All right, let's crack on. So we're going to add on x onto each side, so we're going to end up with 5x, and we're going to add on 3 onto each side, so we're going to end up with greater than 10, so x has got to be greater than 2. Okay, that's easy for 2 marks. Next, factorize this thing. So we need two numbers that will multiply to make negative 24, but also add to make negative 5. They are negative 8 and 3. So we'll get 2x squared minus 8x plus 3x minus 12, got to be less than 0. We're going to factorize both, factorize on the left and on the right. So we'll get 2x lots of x minus 4 plus 3 lots of x minus 4, got to be less than 0. And so we'll get 2x plus 3 and x minus 4, got to be less than 0. So our critical values are x equals negative 3 over 2 and x equals 4. This is U-shaped, 4, negative 3 over 2. So we'll get something that looks a bit like that. Okay, where is it that that's less than 0? Well, the less than 0 section is there. It will be when x is between negative 3 over 2 and 4, but not equal to either of them. Now, question C says both this, double check, is it the same? Yes. And this, both work. So our critical values were negative 3 over 2, 2, and 4. So the first one, we've got x has got to be greater than 2. For the next one, we've got when is x between those two values. Now a between looks like that. Okay, you should remember that from GCSE. So when is it both work? Well, both work here, 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 here. Not 4, not 2, but anything in between them. So x has got to be greater than 2, but also less than 4. All right, next exam question. Have a little look at it, and then we'll start. All right, you might want to have paused it and had a try at it, but this is what we can do. So we've got 3x minus 6 has got to be less than 8 minus 2x. Add on 2x onto each side, so we get 5x minus 6 is going to be less than 8. Add on 6 onto each side, x has got to be less than 14, so x is going to be less than 2.8. Okay, nice and easy. With this though, you see the payoff with this question is that this was more difficult, but this is much easier. Okay, whereas in the other question it was a bit more it was a bit different. The critical values here are going to be x equals 7 over 2 and x equals negative 1. So my quadratic will look a bit like this. So we've got 7 over 2 and negative 1. It's U-shaped. Double check if it's U-shaped. If it's not expanded out, it can be a little bit kind of tricky to spot. Double check if it's U-shaped. 2x multiplied by x is a positive value. So you are going to get a U-shape out of this one. So you're going to get something that looks a bit like this. Okay, we want the section where that's less than 0, which will be when x is between negative 1 and 7 over 2. This is an AND question again. So our critical values were negative 1, 2.8, and 7 over 2, which is 3.5. So we've got the first inequality works when that happens. The next inequality works when this happens. Okay, where's the and? The and is in this section here, in between -1 and 2.8, and so your final answer for C will be -1, 2.8, and x will be smack bang in between. Okay, moving on, last question, have a little look at it and then we'll get started. You can try it out yourselves if you want. All right, first we're going to add on x onto each side. 4x minus 7 is going to be greater than 3. Add on 7 onto each side. 4x is going to be greater than 10. Divide through by 4. X has got to be greater than 2.5. Here, this question, it can be tempting. Because of the way that it looks, it can be tempting to maybe almost try a difference of 2 squares, which would be totally wrong, or factor out an x. Remember, you mustn't do anything with a quadratic until it equals 0. So we get x squared minus 9x minus 36 is less than or equal to 0. Now, trying to factorize this, we need to look for numbers that multiply in that way. So we're going to get x minus 12 and x plus 3. Okay, if you can't work out how I've done that, you need to get practice in your factorizing. So your critical values are x equals 12 and x equals -3. So we get -3 and 12. We want, this is a U-shaped quadratic, it's U-shaped because of this. We want when is that less than or equal to 0. Be so careful to spot things like that. Okay, less than or equal to 0 is going to be when x is greater than or equal to -3, but also less than or equal to 12. Okay, you have to be so careful to spot those less than or equal to. I don't think I've missed any so far. Good. All right. When are they both correct? Well, critical values were -3, 2.5, and 12. So the first one is when x is greater than 2.5. The next one is when x is between -3 and 12. It can be equal to either of them. So when are they both true? Well, they're both true in here, here. Also 12, but not 2.5. So we'd have x has got to be less than or equal to 12, but also greater than 2.5. Be careful with your inequalities there. All right, thanks for watching. Visit numberclub.org to find out some more videos and tasks. And if you get a chance, subscribe to the channel. Thanks, hopefully it helps.